Hello everyone and welcome back to the Code Cube. In today's video, we are solving the Cambridge IGCSE Physics 0625/21 Extended Multiple Choice paper from October-November 2025. As always, don't just watch the solutions. Pause before each question, choose your answer and then compare it with mine. The goal is not just to get answers right today, but to learn the thinking process that will help you to score higher in your actual exam. Let's start with question 1. A student determines the diameter of the metal ball. Which apparatus is needed to get an accurate measurement? A. A ruler and the protractor. B. A ruler only. C. A protractor and a set square. D. A ruler and the two rectangular blocks. Pause the video and choose your answer. A metal ball is curved, so measuring directly with the ruler is difficult and it's inaccurate. Now, by placing the ball between the two blocks, we basically create a flat reference surfaces and can measure the distance using the ruler accurately. The ruler and the two rectangular blocks would be the right option. So whenever Cambridge asks about measuring a sphere, think about creating a flat reference points first, okay? An athlete runs at the speed of 8 meter per second for 10 seconds and then at a speed of 6 meter per second for 12 seconds. Which calculation gives the average speed of an athlete in meter per second? So what's the formula for calculating the average speed? Average speed is equal to total distance divided by total time. Now here average speed is given. I want to find out what is the total distance for both the speeds. So for that what we have to do is we have to multiply the average speed with the total time to get the distance. So the distance 1 is equal to average speed is 8 and the total time is 10 seconds, which will give me 80 meters. Distance 2 is 6 meter per second times 12 seconds, which will give me 72 meters. Now if I want to get the total distance, then I will have to add d1 and d2, that is 80 plus 72, which will give me 152 meters. I'll just make it as d, and if I want the total time, then t1 plus t2. t1 is 10 and t2 is 12, which will give me 22 seconds. Now if you want to calculate the average speed, you have to get the total distance, that is 152, and the total time is 22. Now which option we have to choose based on our calculation? We have to go for this one, option B, 8 times 10 plus 6 times 12 divided by 22. That will be your average speed. Now if you drive at a different speeds during a journey, the average speed depends on the total distance traveled divided by the total time taken, not simply the average of two speeds. Please remember that. Never use average speeds directly unless the times are identical. A piece of paper torn out of an exercise book is shown. Describe how massive object affects the space around it, including the size and direction of the force it would exert on other objects placed in that space. So that's a piece described there. What is being described? Gravitational charge, gravitational field, gravitational mass, gravitational potential energy. Now this is the definition of the gravitational field. A gravitational field will describe the region around the mass where another mass is experiencing a force. So suppose let us say this is a earth, and this whatever the force is there, this is called as gravitational field. So field is basically nothing but a region where the force can act. The diagram shows one liquid floating on top of another liquid. So this is liquid P and liquid Q. Which statement explains why liquid P floats on top of liquid Q? The mass of the liquid Q is greater than the mass of the liquid P. B. The mass of 1 centimeter cube of liquid Q is greater than the mass of 1 centimeter cube of liquid P. Option C. Volume of liquid Q is greater than the volume of liquid P. D. The volume of 1 gram of liquid Q is greater than the volume of 1 gram of liquid P. Always remember, floating depends on density. Density is mass per unit volume. If 1 centimeter cube of liquid Q has more mass than 1 centimeter cube of liquid P, then in that case liquid Q is denser. The denser liquid always stays at the bottom. For example, oil floats on water because oil is having less dense than water. So based on our analogy, we get the matching option, that is B. Now this is the spring question. So suppose let's say this is the stretched spring. So the force, this is the force acting on it, and this is the X. Now for this we will be using the Hooke's law. So Hooke's law is force equal to Kx. Now we need the constant K. So K equal to F by X. So we know that force is measured in newtons and the extension is measured in meters. So the unit of K would be Newton per meter. So always remember, spring constant tells us how much force is needed for each meter of extension. Which statement about the movement of force is not correct? If an object is balanced about a pivot, the resultant movement of the object must be zero. The moment of force is a measure of its turning effect. The moment of a force about a point is equal to force times perpendicular distance from the point. The moment of the force about a point increases when a perpendicular distance of the force from the point decreases. Now, the formula of movement is force divided by perpendicular distance. If the distance increases, movement decreases. Option D says here, the movement increases when distance decreases. This is the opposite of what actually happens. Opening a door is easier using the handle than pushing near the hinge because the distance from the pivot is larger. Bigger the distance from the pivot, bigger turning effect. The momentum of the car changes from 10,000 kg meter per second to 15,000 kg meter per second in a time of 8 seconds. What is the resultant force acting on a car? So the formula of force here is change of momentum divided by time. So the change of momentum is how much? 15,000 minus 10,000 divided by the time is 8 seconds. So this will give you 5,000 divided by 8, that is 625 Newton is the force. So the closest answer is 630 Newton. So your option A is correct. Momentum questions always use force equal to rate of change of momentum. A machine is very efficient. What does this mean? It produces a large amount of power. It uses very little energy. It wastes very little energy. It works very quickly. Efficiency measures how much useful energy is produced compared with the energy supplied. A very efficient machine wastes a very little energy. For example, an LED bulb converts more energy into light and wastes very little as heat, making it is highly efficient. So efficiency about reducing the waste energy. In that case, option C is correct. Diagram 1 shows a colonical flask containing water. Diagram 2 shows a beaker with the same base area as a flask and containing water of the depth D. Which statement is correct? The pressure at P is equal to the pressure at X. A pressure at P is greater than the pressure at Y. The pressure at P is greater than the pressure at X. The pressure at Y is greater than the pressure at X. The pressure in a liquid depends only on the pressure equal to the density times gravity times the depth. So when we look at all the 3 points here, they are same depth in water. Therefore, the pressure is also same. Shape of the container does not matter. So remember, pressure in liquids depends on the depth, not on the shape. So the option A is correct. The pressure at P is equal to the pressure at X. A flask with a tight fitting stopper contains a gas. A gas and flask are initially at room temperature. The gas and flask are cooled. Which row describes the average speed of the gas particles and the pressure of the gas as the temperature decreases? So here we have average speed of the gas particles and pressure of the gas particles. Let's analyze this situation. Cooling removes energy from the particles. So particles move more slowly. Slower particles hit the walls less often with less force. Therefore, the pressure decreases. For example, a balloon is placed in the refrigerator becomes slightly smaller because the gas particles moves more slowly. So less temperature, less particle speed, the pressure also decreases. In that case, the right option is A. Brownian motion is the random movement of microscopic particles in a liquid or gas. Which statement about Brownian motion is correct? A. Brownian motion only occurs when a liquid or gas is heated. Much heavier, fast-moving particles that cannot be seen collide with the microscopic particles. Much lighter, fast-moving particles that cannot be seen collide with the microscopic particles. The microscopic particles move to avoid the fast-moving liquid or gas molecules. So Brownian motion occurs because tiny particles are constantly being hit by the smaller, invisible and fast-moving molecules of liquid or gas. So these collisions happen from different directions, causing random movement. Imagine being blindfolded in a crowd while people keep bumping into you from different directions. You would move randomly, right? So, Brownian motion is evidence that molecules are constantly moving. So, in that case, option C matches our analogy, that is, much lighter, fast moving particles that cannot be seen collide with microscopic particles. The distance between two electricity pylons is 60 meter. The cable that connects to the two pylons is 62 meter in length. Why is the cable longer than the distance between two pylons? A. To allow for contraction of a cable in cold weather. B. To create a slope in the cable for electrons to flow down. C. To keep the current low and voltage high. D. To reduce magnetic fields around the cable. So metal contracts when cooled. If the cable were stretched tightly in the warm weather, it could snap during the cold weather when it contracts. So extra strength allows this contraction. In summer, you will be having slightly sagging cable, while in winter you will be having the tighter cable. So expansion when heated, contraction when cool. So based on our analogy, option A is suitable, that allows for contraction of the cable in cold weather. A glass beaker contains a mass of 0.20 kg of water at a temperature of 20 degrees Celsius. The specific heat capacity of water is 4200 joules per kg degree Celsius. A brass block of mass 0.15 kg is at the temperature of 170 degrees Celsius. The block is carefully lowered into the beaker of water. The final temperature of both the water and the brass is 30 degrees Celsius. What is the specific heat capacity of the brass? Assume that no water is lost and no thermal energy has been transferred to the beaker or the surroundings. Thermal energy lost by the brass is equal to the thermal energy gained by the water. So, energy gained by the water is Q equal to mc change in the temperature. So the mass is 0.20 kg and the energy is 4200 and the change in the temperature is 30 minus 20. So the energy gained by the water is 8400 joules. Now let's check the heat capacity of the brass. So let's use the same formula again. The energy gained by the water is 8400 joules. Now we need to calculate the specific heat capacity for the brass. So let's use the same formula again. So the energy what we have here is 8400 joules and the mass of the brass is 0.15 kg. So now we need the specific heat. Then the temperature difference is 170 minus 30. So this is 8400 equal to 21 C. C is equal to 8400 divided by 21, which will give us 400 joules per kg degree Celsius. So this is the specific heat capacity of the brass. So in thermal equilibrium questions, energy lost is equal to energy gained. In that case, answer A is the right option. Which statement about convection is not correct? It enables water in the pan on a cooker to get evenly heated. It happens in liquids and gases. It occurs because cooler liquid rises above the warmer liquids. It occurs because the density of the liquid decreases when it is heated. So convection happens because warm liquid becomes less dense and it rises. So cooler liquid is denser and it sinks. Option C says cooler liquid rise, which is incorrect. For example, hot air balloons rise because the heated air inside becomes less dense than the surrounding air. So warm rises, cool sinks. So in that case, option C is correct. It occurs because cooler liquids rise above the warmer liquids. Iron is a better conductor of thermal energy than rubber. Which statements explain this? Electrons in iron can move from one part of the iron to another. Electrons in rubber cannot move in this way. Electrons in iron vibrate with more energy than those in rubber. Positive particles in iron can move from one part of the iron to another. Positive particles in rubber cannot move in this way. Positive particles in iron vibrates with more energy than those in rubber. Metals contain free electrons. These electrons move through the metal and transfer thermal energy quickly. So rubber does not have free moving electrons. For example, a metal spoon becomes hot quickly in a cup of tea while plastic spoon remains much cooler. So good thermal conductors usually have free electrons. So in that case, option A is correct because electrons in iron can move from one part of the iron to another. Electrons in rubber cannot move in this way. Two metal cans are identical except that one has a shiny silver outer surface and the other has a dull black outer surface. They each have the same mass of hot water at the same temperature sealed inside them. They are both in a vacuum in the darkness of outer space. How does the temperature of a water in each one change? The temperature of a water does not change. B. The water in the black can cools more slowly than that in the silver can. The water in the silver can cools more slowly than that in the black can. They both cool down at the same rate. In a vacuum, conduction and convection cannot occur. Only radiation transfers the thermal energy. Shiny silver surfaces are poor emitters of radiation, therefore, the silver can lose the thermal energy more slowly. So, black surfaces are good emitters, shiny surfaces are poor emitters. That's the reason the water in the silver can cool more slowly than in the black can. So, option C is the right option. The ray of light reflects from a plane mirror. The angle between the incident ray and the surface of the mirror is 35 degrees. Which statement is correct? The angle of incidence is 35, the angle of incidence is 55, the angle of reflection is 70, the angle of reflection is 110. The question tells us the angle between the ray and the mirror surface is 35 degrees. Many students stop here and immediately choose 35 degrees, but that's the trap. In reflection questions, the angle of incidence is never measured from the surface. It's always measured from the normal. The normal is simply an imaginary line drawn from 90 degrees to the mirror. That's why we draw this as vertical line. The mirror and the normal make a right angle. The right angle is 90 degrees. We already know one part is 35 degrees. So 90 minus 35 will give you 55. Therefore, the angle of incidence would be 55 degrees. Think of the normal as a referee in every reflection question. Physics only cares about angles measured from the referee. It doesn't care about angles measured from the mirror itself. So, whenever you see reflection, find the normal first and then measure the angle. Parallel waves in a ripple tank are diffracted as they pass through a gap in the barrier. Three changes that can be made to this arrangement are listed. Decrease the wavelength of the waves, increase the amplitude of the waves, decrease the size of the gap. Which changes will cause the shape of the diffracted waves to be less curved? Let's look at the statement 1. Decrease the wavelength of the waves. So the waves become less spread out, less diffraction. So the statement 1 is correct. So the next statement is amplitude only changes the height of the waves. It does not affect the diffraction. So the statement 2 is incorrect. Statement 3, decrease the size of the gap. Cambridge expects you to compare the gap size with the wavelength. Making the gap smaller changes how the waves emerge and affect the diffraction. For this question, statement 3 can be taken as correct. So remember, smaller wavelength, less diffraction, amplitude does not affect the diffraction. For example, imagine water waves moving through an opening in an harbor wall. Small waves spread out less than a large waves. That's exactly what happens when wavelength decreases. When you see diffraction, wavelength matters. Gap size matters. Amplitude does not matter. So, only 1 and 3 are correct. That is option B. A beam of light passes through a vacuum and then enters a transparent liquid. The diagram shows the path it takes. So this is the vacuum liquid, the ray of incidence, and this is how it is happening. The light travels through the vacuum at the speed of 3.0 cross 10 power 8 meter per second. So what is the speed of the light in the liquid? So use the refractive index equation here. So the normal is equal to sine I divided by sine R. So now the angle of incidence is how much? Sine 40, and the other one is sine 25. So substitute the values and your normal becomes 1.52. And let's use this formula, V equal to C by N. Let's substitute the value. C is what? C is the speed of light, that is 3.0 cross 10 power 8 meter per second, divided by N is the one what you got, that is 1.52. So this will give you V equal to 2.0 cross 10.8 meter per second. So when light enters a denser material, it slows down. The bending is actually evidence that the speed has changed. More bending means the speed is different in new medium. For example, whenever light bends towards the normal, it means it has slowed down. That's a quick clue that the speed in the liquid must be lower than 3 cross 10 power 8 meter per second. Towards the normal means it is slower. If it is away from the normal, then it is faster. So based on our answer, option B is correct. Which statement about a thin converging lens is correct? All rays of light refracted by the lens pass through the principal focus. All rays initially parallel to the principal axis of the lens are refracted through the principal focus. The focal length of the lens is the distance between the image and the principal focus. The focal length of the lens is the distance between the object and the image. One of the most important lenses rule is any ray traveling parallel to the principal axis passes through a principal focus after refraction. This is the rule that Cambridge loves testing. So now imagine this is the earth and this is the sun. The rays from the sun are almost parallel, and when these rays passes through the magnifying glasses, these rays meet at one point. This point is called as principal focus. Memorize these words: parallel, lens, focus. Okay, in that case, Option B is the correct option, where all rays initially parallel to the principal axis of the lens are refracted to the principal focus. The diagram shows two narrow beams of light, that is P and Q, passing through the same prism. Beam P and Q are both the incident on the same point on the prism and at the same angle. Which row correctly compares the beams P and Q? Only P is dispersed, P is monochromatic and Q is white light. Only Q is dispersed, P is white light and Q is monochromatic. Only P is dispersed, P is monochromatic and Q is white light. Only P is dispersed, P is white light and Q is monochromatic. A monochromatic beam contains only one color. One color cannot split into multiple colors. So beam P must be monochromatic. So we got two options here that define monochromatic. White light contains many colors. When white light enters a prism, the color separates. This is called as dispersion. Therefore, Q is white light. A prism acts like a color sorter. When white light enters, each color bends by a slightly different amount, creating a rainbow effect. So white light disperses, monochromatic light does not disperse. So in this case, P is dispersed, Q is not dispersed. So P is white light and Q is monochromatic light, which is option B. Ultraviolet radiations and infrared radiations are both parts of the electromagnetic spectrum. However, they differ in wavelength and frequency. Which row describes how they differ? Ultraviolet has shorter wavelength, higher frequency. Infrared has longer wavelength and lower frequency. So which matches? Option D. Here I am going to draw two waves. Look at these two waves. The height of the waves is same. The height represents the amplitude. Since the height hasn't changed, the loudness stays the same. Now look at the spacing. The second wave has peaks closer together. Closer peaks means higher frequency. Since the frequency changes, the pitch also changes. That's why the amplitude is constant, whereas frequency is varying. So here, so based on our analogy, the answer is B. So now, for example, think of a piano. You can press different keys softly. The loudness stays similar, but the note changes because of the frequency changes. Okay, I hope you understood this. The diagram shows part of the magnetic field around two magnets. Which list gives the order of magnetic field strengths at the position P, Q, R, S? From the weakest to the strongest. Sorry, not yes, it's the South Pole. So just PQR, okay? So here, magnetic field strength depends on how close the field lines are. So closer field lines means stronger magnetic field. Farther apart field lines means weaker magnetic field. Now look at the diagram. Point R is far away from most of the field lines. So R is having the weakest field. Point Q is closer to the magnets. So Q is having the stronger field. Point P is where the field lines are most concentrated. So the P is having the strongest field. Therefore, the weakest is R, then comes Q, and then P is the strongest one, which is option D. Now let's understand this situation with an example. Imagine people are standing in a queue. If people are packed closely together, the crowd is dense. If people are spread out, the crowd is weak. So magnetic field lines work in exactly same way. Closer together means stronger. Whenever you see magnetic field diagrams, don't count the lines. Look at their spacings. The closer the lines, the stronger the magnetic field. A fully charged battery stores a charge of 1800 coulomb. A battery is charged with a current of 830 milliampere. How long does it take to fully charge a completely discharged battery? This is straightforward electricity calculation. Let's see if you remember the formula. So we know the formula is Q equal to IT. Q is what? The charge, that is 18,000. Then the current is 830 milliampere. So let's convert it to ampere. So it becomes 0.83 ampere. We need to figure out the T. That is what how long means you need to check out the time. So T is equal to 18,000 divided by 0.83, which will give me 21687 seconds. So here when we look over here, it's either in hours or it's in minutes. So let's get the time in hours. So for that what you have to do is 21687, you need to divide it by 3600. This will give you in hours. So it is 6. So it is 6 hours. Do you have anything option? Yes, option D is the right one. What is the definition of electromotive force? The electrical work done by a source in moving a unit charge around a complete circuit. The electrical work done by a unit charge passing through a component. The mechanical work done by a source in moving a unit charge around a complete circuit. The mechanical work done by a unit charge passing through the component. Don't worry about the scary names. This question is actually testing a definition. So electromotive force is the energy that is supplied by the source to each coulomb of a charge. So in simple words, a battery gives energy to charges and pushes them around the circuit. The amount of energy given to 1 coulomb of charge is called as electromotive force. So it's basically EMF is nothing but it's an energy supplied per unit charge. And you can also write it like EMF is equal to energy divided by charge. Imagine giving 100 rupees to each student in the class. The amount each student receives is similar to the energy each coulomb receives from the battery. If the question says energy supplied by the source, think it's electromotive force, and the definition is given in option A, that is the electrical work done by a source in moving a unit charge around the complete circuit. A cell passes a current of 2 ampere in a circuit for 30 seconds. In this time, the cell transfers 120 joules of energy. What is the electromotive force of a cell? First, let's find out the charge. So what's the formula? It's Q equal to IT. Now, Q is equal to, what is the current? Current is 2 ampere and the time taken is 30 seconds. So Q is 60 coulomb. Now let's use the EMF formula. EMF is equal to energy divided by charge. So the energy is what? Energy is 120 joules. Let's write 120, and the charge is 60 coulomb. So the EMF is 2 volt. So do we have 2 volt answer? Yes, it's option C. So this is simple. The battery is transferring 120 joules. That energy is shared among 60 coulombs. So each coulomb is receiving 2 joules. Therefore, the electromotive force is 2 volt. That's it. The diagram shows 2 resistors in series connected to the power supply. The reading of the voltmeter is 3 volt when the switch is closed. What is the resistance of resistor R? This is a classic series circuit question. Take a moment and try it yourself, okay? So remember, in the series circuit, the current is same everywhere. So let's find the current through the 6 ohm resistor. So for this, you need to use the Ohm's law. I'm going to erase this. So the formula for the Ohm's law is V equal to IR. We know the voltage across the 6 ohm resistor is 3 volt. We need to figure out the current, and the resistor is 6 ohms. So the current would be 0.5 ampere. Now we know the current in the whole entire circuit, that is 0.5 ampere. Let's find out the total resistance, that is V by I. We know that total voltage given is 12 and the current is same, so it's going to be 0.5, which will give you 24 ohms. So this is the total resistance in the circuit. Since the resistors are in series, so we have the total resistance is equal to the R, that is this one, and the other resistor is having 6. So we know what is the total resistance, that is 24. 24 equal to R plus 6, then your R would be 18 ohms. So that is the value of R. So we have it. Wait, this doesn't match the options. Let's look carefully at the diagram. The voltmeter is connected across the resistor R, not the 6. So the voltage across R is 3. Now let's calculate again. V equal to IR. So V is 3, I times R. Now the remaining voltage across the 6 ohm resistor is 12 minus 3 is equal to 9 volt. So the current would be 9 divided by 6, that is voltage divided by the resistance. So you get the current as 1.5. So we know the I, we know the voltage across the resistor R because the voltmeter is connected here. So in that case your resistance would be 3 divided by 1.5. So the resistor value is 2 ohms. Do we have 2 ohms? Yes, option D. Think of voltage as money being shared between two people. If one resistor gets 3 volt, the other gets the remaining 9 volt. So the total must always add up to 12. Lamps can be connected in series or in parallel to a power supply. What is an advantage of connecting the lamps in parallel rather than in series? All of the lamps can be switched on and off using the same switch. Fewer connecting leads are needed to make the circuit. When the lamp stops working, the others may continue to work. Less power is transferred from the supply. In the series, all the lamps are connected in one part. If one lamp breaks, the circuit becomes incomplete. Every lamp goes off. In parallel circuit, each lamp has its own path. If one lamp fails, the others still have complete path. They continue working. So imagine a building with 3 staircases. If one staircase is closed, people can still use the other two. That's exactly how parallel circuits work. So the advantage of connecting the lamps in parallel is when the lamp stops working, the others may continue to work. The lamps on the bicycle are powered by the simple electrical generator. A permanent magnet rotates around a stationary coil of wire wound on an iron core. Which statement is correct? The current in the lamp decreases as the speed of the rotation increases. The current in the lamps decreases when the magnet is replaced by a stronger magnet. The output electromotive force will be higher if the gap between the magnet and the coil is bigger. The output EMF will be higher if there are more turns on the coil. This is electromagnetic induction, one of the Cambridge favorite topic. Electromagnetic induction happens when magnetic field lines cut through the coil. More the turn of the coil has, the more the field lines are cut, the greater the induced EMF. The faster rotation increases the EMF, not decrease it. A stronger magnet increases the EMF. A large gap weakens the magnetic field and reduces the EMF. So in that case, only option D definitely increases the output. Imagine catching rain with bucket. One bucket catches some rain, 10 buckets catch much more. So more coil turn means more opportunity to generate electromotive force. So to increase the induced EMF, you need to have stronger magnet, faster movement and more coil turns. A current carrying coil in the magnetic field between the poles of two magnets experiences a turning effect. Which change would decrease the turning effect? Decreasing the distance between the magnets, increasing the current in the coil, using stronger magnets, decreasing the number of turns on the coil. This is motor effect. Think about what makes a motor stronger or weaker. A large turning effect occurs when the current is larger, magnetic field is stronger, more turns are present. So reducing the number of turns reduces the turning effect. For example, imagine pushing a revolving door. If more people pushes together, the turning effect increases. Fewer people pushing means a smaller turning effect. So which changes would decrease the turning effect? Decreasing the number of turns on the coil would decrease the turning effect. Cables transmit electric power from the output of the transformer at the power station to input of another transformer at the substation. transformer at the power station and transformer at the substation. This is the output and this is the input. This is the cable. The power at the output of a transformer at the power station is 400. Which situation delivers the most power to the input of the transformer at the substation? This question is testing whether you understand the power losses during transmission. When transmitting electricity over a long distance, some energy is lost as heat. The energy loss depends on the current. So power companies increases the voltage. When voltage increases, current decreases. So lower current means less heating. So now why we are using large cables? Large cables basically have lower resistance. Lower resistance means less energy loss. So the best combination is higher voltage and large diameter cable. So for example, imagine transporting water. A wide pipe allows water to flow more easily than the narrow pipe. So large electrical cables work in a similar way. In that case, option C is the right one. Pu is an isotope of plutonium. The nucleus can absorb a neutron and then split to form two other nuclei. Two nuclei that form are gold and phosphorus. In this reaction, neutrons are also produced. What is the number of neutrons produced when the nucleus splits? Don't panic when you see nuclear questions. Let's take step by step. So what is happening here? Let's write it down. So here 239 plus 1 will give you 240 and 207 plus 31. These are the mass numbers what we are comparing. So what is missing here? Let's get the difference. 240 minus 238 will give you 2. So it is going to form 2 neutrons. So the total nucleon must be conserved. Think of it like balancing an equation in the chemistry. So if 240 nucleons start the reaction, 240 nucleons must finish it. So we are missing 2 nucleons. Therefore, 2 neutrons are produced. So do we have that? Yes, option B. So always check mass number before atomic number. So most nuclear MCQs become much easier. 3 statements about alpha particles, beta particles are listed. The magnitude of a charge on an alpha particle is twice the charge of the beta particles. The mass of an alpha particle is larger compared to the mass of beta particle. The kinetic energy of an alpha particle is smaller compared to the kinetic energy of beta particle. Which statement help to explain the different ionizing effects on alpha particles and beta particles? This question looks squarey, but it's actually testing properties of alpha and beta radiations. So alpha particles have double the charge, much greater mass. Because of this, they interact slowly with atoms. As they move through matter, they knock electrons out very effectively. This creates many ions. That's why alpha particles are highly ionizing. When we look at the statement 3, the kinetic energy comparison does not explain the ionizing difference. So statement 3 is not needed at all. Imagine rolling a bowling ball through a row of plastic bottles. It causes much more disturbance than a ping pong ball. Alpha particles behave like a bowling ball. So as we don't need statement 3, we only need 1 and 2. Remember, alpha is most ionizing, least penetrating. Okay. A beta particle is a fast moving electron. Which statement explain how beta particles are emitted from an atom? An electron is emitted as a beta particle from an inner electron shell of an atom. An electron is emitted as a beta particle from an outer electron shell of the atom. A neutron changes into a proton and beta particles is emitted from the nucleus. A proton changes into neutron and beta particle is emitted from the nucleus. This is a favorite Cambridge radioactive question. Inside the nucleus, a neutron changes into proton. During this process, an electron is created and emitted. That emitted electron is called as beta particle. The electron does not come from an electron shell. It comes from the nucleus. That's the important idea. Think of a factory machine producing a new product. The electron is created during the nuclear change itself. It wasn't already sitting outside waiting to leave. So in that case, Option C is the right option. A neutron changes into proton and beta particle is emitted from the nucleus. Which property must a radioisotope have for its radiation to make it suitable to kill bacteria in food? Think carefully about both the radiation type and the half-life. To kill bacteria inside food, the radiation must penetrate the food. Alpha particles cannot do this. Gamma rays can. So we need gamma radiations. The source should remain useful for a reasonable period. Several hours is suitable. Less than 1 minute would be impractical. Hospitals sterilize equipments using gamma radiation because it can reach areas that ordinary cleaning cannot. The same principle is used in food irradiation. So option C is the right answer. A student tries to predict the effect of exposure time on the radiation dose received from the source of ionizing radiation. Radiation dose measures the amount of ionizing radiations received by the living organisms. Which graph shows the corrected trend between the variables? So these are the graphs. Before looking at the graphs, ask yourself a simple question. The longer you stay near the radioactive source, the more radiations you receive. Double the exposure time, approximately double the dose. Therefore, the graph should be straight line through the origin. So which one does that? Option A. So let's understand this with an example. Imagine filling a bucket with water. The longer the tap runs, the more water enters the bucket, right? Radiation dose increases in the same way. So more time near the source, greater the radiation dose. A satellite is in the orbit around the Earth. The orbit has radius r and period t. Which expression gives the orbital speed of the satellite? This is actually a circle question disguised as a space physics question. Take a moment and try it, okay? So we have an Earth. So this is satellite. So satellite travels around the circular orbit. So one complete orbit means it travels the circumference of the circle, and the circumference of the circle is 2 pi r. So the time taken for one orbit is t. So the speed is always distance divided by time. So the distance is what? 2 pi r, and the time is t. The speed would be 2 pi r divided by t. So option C is the right answer. Comets move around the sun. Which statement describes the orbit of the comet? Orbit is circular with the sun at the center of the circle. The orbit is circular with the sun not at the center of the circle. The orbit is elliptical with the sun at the center of the eclipse. The orbit is elliptical with the sun not at the center of the eclipse. So this is purely theory questions. Don't overthink. Comets do not travel in the perfect circles. Their paths are elliptical. An eclipse looks like a stretched circle. The sun is not the center of the eclipse. Instead, it sits near one side. This is why comets spend more time very close to the sun and some time very far away. Think of an athletics track. It's stretched rather than perfectly circular. A comet's orbit is similar. So in that case, the orbit is elliptical with the sun, not at the center of the eclipse. A galaxy is at the distance of 60 million light years from the Earth. The galaxy is moving away at the speed of 1300 km per second. 1 light year is about 9.5 times 10 power 12 km. There are about 3.2 times 10 power 7 seconds in 1 year. So which expression can be used to estimate the age of the universe in years? Don't panic because of the big numbers. This question is actually testing one simple idea. Scientists estimate the age of the universe using time equal to distance divided by speed. So the galaxy distance is given in light years. The speed is given in kilometer per second. So first we convert the distance into kilometers. What's the distance? Distance is 60 million light years. So we write it as 60 times million is 10 power 6. So multiply it with 9.5 times 10 power 12 kilometer. So according to this formula, T is equal to 6 times 10 power 6 times 9.5 times 10 power 12 divided by 1300. So this gives the seconds. To convert the second into years, you have to divide this by 3.2 times 10 power 7. So which option is matching this? It is B. So if someone tells you I travel 300 kilometers at 60 km per hour, you automatically calculate time equal to distance divided by speed. This question uses exactly the same idea, just on a cosmic scale. That's the end of the Cambridge IGCSE Physics 0625 cross 21 October November 2025 extended multiple choice paper. If you found this paper challenging, that's completely normal. Extended papers are designed to test both your physics knowledge as well as your problem solving skills. Remember, understand the concept, learn the common exam tricks, practice consistently, review your mistakes. Every paper you solve gets you one step closer to that A or A star. If you enjoyed this walkthrough, don't forget to like, subscribe, and share it with a friend who is preparing for physics. I will see you in the next paper solving session.